Alright, these are the special parallelograms notes that we started in class today. I told you I would try and upload the video, so we'll see how long these take, especially because if I try to work out all the example problems, it's going to take a while. So, let's see how long this is going to be. I still might skip a couple, but you have them completely worked out in your completed note section of your module. Okay? So just as a review, parallelograms have all of these very specific characteristics. Okay? Parallelograms have parallel opposite sides, congruent opposite congruent angles, consecutive angles are supplementary, and diagonals bisect each other. On top of those five characteristics, a rhombus has those five characteristics, including three new ones. Now, instead of just those parallelogram properties that still hold true, a rhombus has four congruent sides. So now all the sides are equal. The diagonals are now perpendicular, so if I zoom in here, very, very much zoom in here, every one of these creates a 90-degree angle. Okay, so it's almost like drawing a complete square in the middle, because now we have four right triangles that all have a right angle in the middle. Okay, and the diagonals bisect our opposite angles. So I'm going to zoom in again. This angle is congruent to this angle. This angle is going to be congruent to this angle. Okay, but they're bisected, so those angles are cut perfectly in half. Okay, so those are the rhombus, or rhombi, or as Megan likes to call them, rhombi. But if we go back to parallelograms, those five characteristics, rectangles have those five characteristics, including these two. Okay, now if I look, we have four right angles, four in the corners. Okay, and the diagonals are congruent. Okay, so this red line is congruent to the blue line, and because they bisect each other, they're all a little equal like that. Okay? And the parallelogram of all parallelograms is our square. Okay? Because squares have all of these characteristics. Okay, every single one of them. So many that, like, if I were to try and draw them all inside that square, I would need a way bigger picture. Okay, so those are our properties. If you go to the next slide, it looks a little something like this. This is just another way to look at it. Inside the box of parallelograms, we see that everything inside this box has all the properties of a parallelogram. But if we split it up in our Venn diagrams, our rhombuses have all these characteristics, our rectangles have all these characteristics, and we see that the only shape that has a combined characteristic or shares all of them are the squares. Okay. Okay. So, examples. Alright, so I'm going to zoom in on all of these and try and write as best as I can, but we know technology is wonderful and screws up a lot, so hopefully this works well for us. Okay, so we're going to use all this information to identify all of our missing sides, okay? So first they ask for QR. So by definition, QR is going to be the same length as PS. So QR has to be 10. Next they ask for SR. SR by definition has to equal PQ, so SR is 24. Okay, one of the things I noticed looking at this picture is I do have my diagonals in there. Okay, and that's going to come in handy in terms of what I do next, okay, because it's asking me to solve for SQ. SQ is the diagonal, okay, and if I trace this particular part of the triangle in orange here, I see I actually have a right triangle. Okay, so if I were to draw that down here as best as I can, I know that SR is 24, and I know that QR is 10. So we need to do the Pythagorean theorem to solve for side C. Okay, so this is where C squared equals 24 squared plus 10 squared. And when I add those together, 24 squared plus 10 squared, I get 676. So C squared equals 6, using technology all the time, 676. So to get C by itself, we square root both sides. So C is 26, I think. Yep, 26. So if I zoom back out, that means SQ has to be. That also means that PR has to be 26, because by definition of a rectangle, my diagonals are equal to each other. And QT is half the diagonal, so 26 divided by 2 is 13. Okay. Question 2. AC is going to be the whole diagonal, so 15 plus 15 gives me 30. So this whole thing right here has to be 30. It's a really messed up looking line. Because my diagonals are equal, that means BD also has to be 30, which means BE is 15. AB is the same length as DC, so 27. And BC is the side, so we're going to use the Pythagorean theorem again. Knowing that my hypotenuse is 30 and my base is 27, I don't know this missing side length, so Pythagorean theorem tells me a squared plus b squared equals c squared. So a squared equals 30 squared minus 27 squared. And if I plug that in, 30 squared minus 27 squared is 171. So A is going to equal, when I take the square root of both sides, 13.07. Okay, so the length of this box, or the width of this box, is 13.07. Okay, let's look at number 3. One of the things that I know about number 3 is that I understand that this angle right here in red is 27, which means that this angle down here is also 27. Okay. I also know now that all of the angles in a rectangle have to be 90 degrees. So if I take 90 minus 27. It's going to give me an angle of 63. So I'm going to zoom in here. What? Okay, so if I zoom out, this angle over here is also going to be 63. Okay, so here's the cool thing about rectangles. I'm going to see if this works with a highlighter. Every one of these triangles that's created in my rectangle is an isosceles triangle. Okay, so in that purple triangle, if that bottom right corner is 27, by definition of isosceles, this angle over by M is also 27 degrees. Which means the one up top by angle K is also 27. And we can do the same thing for 63. Okay, so I have all of my angles labeled. Now it's just a question, oops. Of solving what this question's asking me to solve for. Okay, and I'm trying to highlight, or I'm trying to erase my purple triangle so that way, oh, I'll just write it back in there. So that way I can highlight what angle I'm trying to solve for over on our answers. Okay, so this is 63, this one is 27. Okay, measure of angle MJK. So let's get our angle measure here. MJK looks like that. 90 degrees. Okay. MJL 63. JLK also 63. KML 27. MNL. Ooh, so this one wants to know this angle right here. And this is one of those cool cases where purple triangle is going to come back. All the angles of a triangle have to add up to 180. So I know that in order to solve for that green angle, 180 minus 27 minus 27 is going to give me my green angle there. Okay, so 180 minus 27 minus 27, 126. 126 degrees. Okay. Ladies and gentlemen, this is the exact same idea. Okay? And we did this one in class, so this one should kind of be a pretty quick review. I'm going to zoom in here because we figured out these angles already in class. 180 minus 64 is 116 divided by 2 is 58. So I know that this angle right here and this angle over here is also 58. And remember, I got that because that's an isosceles triangle. 58 plus 58 plus 64 has to equal 180. Okay. And then I'm going to just go down here to this other triangle down here, sorry. I'm going to go ahead and label my 58, and that's going to be 64, okay? And now let's look at the blue one. This right here is 116. This is 116. which means this is 32. This is 32. (32), 32. Okay. Measure of x, w, y, 58 degrees. Y, x, z, 32 degrees. W, v, z, 116. X, W, Z, 90. And X, Z, Y, 58 degrees. Sorry, guys. Okay. This is why I did. Alright, let's go ahead and look at this one. We have some random little pen marks all over, but that's fine. Looking at this one, it says find EF, and it tells me that CD is 3x plus 5 and EF is 7 minus 39. Definition of rectangles tells me that those sides are actually congruent to each other, so we're going to set them equal to each other. So we have 3x plus 5 equals 7x minus 39. Okay, I'm going to zoom in here so I can work and hopefully not cause chaos. I'm going to subtract 3x from both sides. So 5 equals 4x minus 39. So we add 39 to both sides. So 44 equals 4x. Divide both sides by 4, x is 11. A lot of people just stopped there, but we can't because the directions say find EF. So because the directions say find EF, we're actually going to take the fact that x equals 11 and plug it into our side. So we have 7 times 11 minus 39. Okay. 7 times 11 is 77. 77 minus 39 is 38. Okay. Number 7. If RT equals 5x minus 14 and US is 2x plus 10, find VT. So, oh, okay. I'm tired. Here's the thing about our diagonals. We know they're congruent, which means they're equal to each other. So 5x minus 14 has to equal 2x plus 10. So if I subtract 2x from both sides, now I add 14 to both sides. I get that x equals 8, which is awesome, except it wants to know VT, and VT is half of RT. So if I can take this x equals 8, plug it into RT, and then divide by 2, I have what VT is. So 5 times 8 minus 14. So 5 times 8 minus 14 is 26. divided by 2 is 13. Alright, so looking at question number 8 now, Jm is x plus 7, and mk is 5x minus 23. Find JL. So one of the first things we're going to have to do is I noticed that Jm is half of a bisector. So Jm is this, and mk is this, and I know because we have a rectangle that they're equal to each other. So I'm going to set both of them equal to each other. X plus 17 equals 5x minus 23. So x plus 17, 5x minus 23. And we're going to go ahead and solve for x. So I'm going to subtract x from both sides. And I'm going to add 23 to both sides. And I get that x equals 10, which is awesome, but it's not what this problem's asking me to solve for. This problem wants me to solve for JL, which is the whole diagonal. So what I'm going to do is I'm going to plug it into JM. So 10 plus 17. That's going to give me half of a diagonal. So I'm going to multiply it by 2 to get the full diagonal. So I know 2 times 27, which is going to give me 54. Okay? Looking at question number 9 now, I know that VW is 9x minus 11 and SU is 16x minus 12. Find WT. So the first thing I notice is that they give me VW. VW is only half. And they also give me SU. SU is the whole diagonal. So there's two possible ways we can do this. We can multiply VW by 2, or we can divide SU by 2. So I think it might be easier for us to take VW, might be easier for us to take VW by 2. So when I multiply VW by 2, I multiply that whole equation by 2. So I'll get 18x minus 22. So now I know the whole length of VT. Okay, so again, diagonals of a rectangle are congruent to each other. So I'm going to set these both equal to each other. So 18x minus 22 equals 16x minus 12. So I'm going to subtract 16x from both sides. I get 2x minus 22 equals negative 12. So if I add 22 to both sides, I get 2x equals positive 10, which means x equals 5. So again, awesome, but it's not what they're asking me to solve for. They want me to find WT, which is half of VT. So if I can find the whole VT, I can take that number and divide it by 2. So what we can do is we can plug that in to 18x minus 22. So 18 times 5 minus 22. 18 times 5 is 90. Minus 22 gives me 68. So WT equals 68. Okay. But I just realized I made a mistake. I just solved for VT. So to find WT, I have to divide that by 2. So 68 divided by 2 oops, was 34. So WT is equal to 34 degrees. Alright, so now we're still dealing with some rectangles, okay? So find the measure of BCE. So I'm going to go ahead and highlight what angle measure they want me to solve for, BCE. So BCE. And I notice that BCE is the other half of this angle right there, of angle C. So one of the things that we talked about when we did our notes, in our notes we know that all of our sides of a rectangle are parallel to each other, which means that these two angles that are given here in this problem, 7x plus 5 and 11x minus 3, these are alternate interior angles. So that means that they're congruent to each other. So to solve for BCE, I can set them equal to each other and solve for x. So 7x plus 5 equals 11x minus 3. Okay, so we're going to solve for x. We're going to subtract 7x from both sides. So 5 equals 4x minus 3. Add 3. I get 8 equals 4x. X equals 2. Okay, but it wants BCE, and I know that whatever 11x minus 3 is, plus this mystery angle has to equal 90. So what I'm going to do is I'm going to plug in the number 2 into this to figure out what that little mystery angle is. So 11 times 2 minus 3, so 22 minus 3, oops, is 19. So I know that this little angle right here is a 19-degree angle. Okay? Because it's a 19-degree angle, that works fine because I know 19 plus something has to equal 90 because that's a 90-degree angle right here. So in order to solve for my missing angle BCE, the measure of angle BCE is going to be 90 minus 19. So BCE is equal to 71 degrees. Same idea with this one. We're going to take JHI. I'm going to highlight JHI. JHI is this one right here. So I know that this, angle, wow, okay. This angle right here is the same as this angle right here because of alternate interior angles. But looking at these angles here, I know that they have to add together to equal 90 degrees. So I'm going to add them together to equal 90 degrees. Okay, so because I know these two angles add up to 90, I can actually add them together. So we can do a 3, oh, that doesn't look like a 3. 3x plus 2. Oh, I'm sorry. Plus 12x minus 17 equals 90. We can combine like terms. We have 15x minus 15 equals 90. Add 15 to both sides, so 90 plus 15 is 105. Um, 105. Divide both sides by 15. X equals 7. So again, awesome, but I need to plug it in to find that angle JHI. So we're going to plug it in to this one right here, because remember, alternate interior angles. So we have 3 times 7 plus 2 is 20. And that's our answer. Looking at number 12. I'm going to do the same idea. We're going to highlight Z, X, ZW, X, ZW. Cool. X, ZW. Okay. So I'm looking for this angle right here. So looking at this picture, one of the first things that I notice is that these two angles are on the same side of that diagonal, which means if I draw this, that means both of those angles are in the same triangle, which means I can add them together with the fact that that's a 90-degree angle. I can add them all together because they'll all equal 180 because it's the same triangle. Okay? So I know that I can take x plus 20. I know that I can take x plus 20 plus 5x minus 8 plus 90 equals 180. Assuming this will stop going back, we can combine like terms from here. So x and 5x gives me 6x. 20 minus 8 plus 90 is 102. Equals 180. If I subtract 102 from both sides, 180 minus 102 is 78. Divided by 6. X is 13. So remember, if I know that x is 13, I can take that and plug it in here to figure out this little itty bitty angle. So 13 plus 20 is 33. But I'm looking for the opposite side of that angle, right there in purple. Okay? So to find it, I know that 33 plus something has to equal 90 degrees. Okay? So I'm going to take 90 minus 33. Gives me a 57-degree angle. And that's my final answer. Question 13, solve for x. Okay, so the first thing I noticed about this problem, sorry I had to look at it for a second, is that if this angle is 134, this angle here in purple is going to be 180 minus 134 because they're linear pairs. So that's a 46-degree angle. I don't know why I zoomed in so much. It's 46 degrees. Okay, and so now I'm going to focus just on this little mini angle right here in purple. Okay, so if I redraw this like this, I know that this top angle is 46. And I also know because this is a rectangle that those sides have to be equal. Okay, and I also know from the picture that this is 5x plus 7. Because this is an isosceles triangle, this side over here is also 5x plus 7. So what I know about all three of these little angles here of this triangle is that I can actually add them together and equal 180 because all triangles have to add up to equal 180. So we get 10x, 7 plus 46. So 46 plus 14 is 60 equals 180. Subtract 60 is 120. So 10x equals 120. X is 12. Well, okay. Alright, ladies and gentlemen, now we have some rhombus questions. And rhombuses, rhombi, whatever, they're pretty cool because all the sides are congruent. So because I know that JK is 12, I know JM by definition is also 12. Okay. And I also know that JN is 7. So if this is 12, if this is 12, why is this not working? This is 12, which means if this is 7, this is 7. So JL, the whole thing, is going to be 14. So to solve for MN, unfortunately, because this is a rhombus, I know those are going to be 90-degree angles, so I need to solve for this purple side here. Okay, and the only way to do that is the Pythagorean theorem. So if I draw that right triangle as best as I can, 12, 7, and I need to solve for x. So I know x squared plus 7 squared equals 12 squared. So x squared equals 12 squared. Okay, and to solve for x, we actually just take the square root of both sides. Okay, so mn, so if I take 12 squared minus 7 squared equals 95, square root of 95 is 9.75, which means the whole length of mk, 9.75 times 2, 19.5. Okay. EF is 23. That means all of the sides are 23, so that means GF is also 23. That's pretty much all I know. And I also know that inside we have this, and I also know that the other side, DF, this whole thing right here is 40. Okay, so the whole thing is 40, which means I know that half is 20. Okay, so to find HF, we took it and divided it by 2, so that's how I got 20. To find GH, this green side of the triangle, I'm sorry, that's not GH. This is GH. Okay, so I have to do the Pythagorean theorem again, because I know all the outside sides are 23, and I know this side is 20, so we have to use that to solve for x. So x squared plus 20x equals 23 squared. X squared equals 23 squared minus 20 squared. Square root both sides. Square root of 23 squared minus 20 squared is 11.4. So GH is 11.4, which means this whole thing, GE, is going to be 22.8. Okay. RT is 22, US is 18. Okay. So RT is 22, so this whole thing is 22. So if I zoom in, this is 11, this is 11. US is 18, so this whole thing is 18, which means this is 9. That doesn't look like a 9, sorry. That is 9, and that is 9. So let's first see if there's anything that I can fill in using that information. VT, 11. UV, 9. RS can't solve for it yet. ST can't solve for it yet. But I do recognize that these two are side lengths, so I know that if I find one, I've found the other. So Pythagorean theorem, Okay, so this is 11, this is 9. So to solve for my side, x squared is 11 squared plus 9 squared. Square root both sides. So the square root of 11 squared plus 9 squared is 14.2. So both of our side lengths, 14.2. Alright, so ladies and gentlemen, now we're just dealing with angles. First thing I see off the top of my head is that angle 8 is 90 degrees, because all of them are 90 degrees. One of the cool things I know about rhombuses is that the angles have been bisected, which means I know that angle 3 is also going to be 38 degrees. Okay, so angle 3 is going to be 38, angle 5 is going to be 38, angle 4 is going to be 38. Okay, so to solve for all of our other missing angles, to solve for angle 7 here, I know that this is a 90-degree angle because they're perpendicular. So all the angles of a triangle have to add up to 180. So I'm going to take 180 minus 38 minus 90. That's going to give me angle 7, which is 52. Which means angle 6 is also 52. Which means angle 1 is 52. And angle 2 is 52. Angle 5, ZY is 34. So I know that's 34, which means, what over here can we do? If ZY is 34, WZ is also... Oh, that doesn't work, does it? Okay, whatever. It's 34. VY, I don't know that yet. ZX, don't know that one yet either. Okay. And then I also know that ZY is 38. Which means half of 38 is 19. Okay. So let's just go ahead and do the Pythagorean theorem just to be safe. 34, 19, this is my missing side. 34 squared minus 19 squared under the square root. So my missing side is 34 squared minus 19 squared under the square root. So square root, oops. Is 28.2. So that means that here in purple, 28.2. Okay, so ZV is 28.2, which means ZX is double that. 28.2 times 2 is 56.4. So 56.4. And VY is 19. We use that to solve for that. Okay. And then inside of our triangle, we know that ZXY is 34. Whoa, wrong part. Right here. Which is 34 degrees. So if I know that that is 34 degrees, WXZ is also 34 degrees. Because the angles are bisected. WVZ is 90. ZY ZYW is going to be right here. So to solve for that missing angle, we're going to use the fact that that's 90. 180 minus 90 minus 34 is going to give me 56. So if this angle right here is 56, that angle right there is also 56. So ZYW is 56. XYW is also 56. Okay. We have squares, and let's hope that we don't get very many technical difficulties with our squares. And we have a few more rhombus questions on here too. So let's go ahead and check these out, okay? Number 6, ABCD is a square, AD is 11, find each missing value. Squares by definition, all the sides are the same. So ABCD is a square, AD is 11, so BC is also 11. EC, AB, okay, so this is what we're going to do because we have to solve for AC and BD. So our diagonals are going to be equal to each other. And this is probably going to rock your mind just a little bit. One of the things that I know about these squares is that all the corners are right angles, right? Which means I can create a right triangle like this, okay? So when I do that, to solve for AC, it's going to look a little something like this. Fix it up just a little bit because you know how bad I am at these things. And I know that all the sides have to be 11. Okay, now I don't know if you realize this, but our diagonals of a square bisect the angles, which means that if I zoom in here, your mind again might just be blown, but this right here would be a 45-degree angle, and this is a 45-degree angle. So then by definition, if this side is x and this side is x, my hypotenuse is x square root 2, which means that that missing length of AC is 11 square root 2, which means BD is also 11 square root 2, which means EC, which is half of it, I'm going to zoom in here so we can do a fraction, 11 square root 2 divided by 2. And we can plug them into the calculator if we really want decimals. Okay? So DAB, let's look at our angles now. DAB, 90. AEB, 90. CBD, 45. And BAC is also 45. So these are all our angles. Okay, so let's look at this next square, number 7. If PQRS is a square and TR is 17, find each missing value. So real quick, I know that TR is 17, which means that this whole length here is 17 times 2. And 17 times 2 is 34. Okay, so if I zoom out, I know that PR is 34, which means QS is also 34. QT, half of it, 17. But now PQ, okay? And this goes back to the idea that if I look at this square, and I'm going to use yellow now, My diagonals, remember, create 90-degree angles, so I have a little 90-degree angle here. And this side is 17, this side is 17, and those are 45 degree triangles. So those are our special triangles. Okay, so if this is 17, this is 17, this is 17 square root 2. Okay, so that missing PQ side is 17 square root 2. And our angles are almost all going to be the same as the last one because they're either going to be 45-degree angles or they're going to be 90-degree angles. So PRS, 45, STR, 90, PSR is also 90, and QPR is 45. Okay, so we have some other rhombus-y looking ones, but I think the rhombus ones on I completed them on the PDF, and I'm fairly certain that the rhombus ones on your homework are not similar to this. So, and these are almost identical to the ones that we've already done. So, I'm going to skip these ones in our notes. If you would like me to work them out, come on to tutorials or ask me in a free time in class and we can work them out together. But I'm skipping these ones. It'd help if I knew how to spell skip.